Before video could be paused, replayed, or stored, television vanished the moment it was broadcast. Then a small California company gave it a memory. Ampex transformed radio, music, television, and even the images sent back from space. Its machines stood at the center of the recorded world. But the company that helped create the future could not keep pace with it. This is the rise, collapse, and surviving legacy of Ampex. Today, television remembers everything. A live moment can be paused, replayed, clipped, streamed, and stored almost forever. But in the early 1950s, television had almost no memory at all. If a program went out live, it was gone. Broadcasters could point a film camera at a television screen, a process called kinescope recording. But the result was slow, expensive, and visibly worse than the original broadcast. Then a small engineering company in California built a machine that changed the nature of television. It made pictures on a screen recordable, editable, and repeatable. That company was Ampex. For a time, it stood at the center of the recorded world. Then it lost nearly everything that had made it powerful. This is the story of the company that taught television to remember, and then watched the future move on without it. Ampex did not begin with television, or even with sound. Its founder, Alexander Matthew Poniatoff, was a Russian-born electrical engineer who had made his way to the United States. In 1944, he established the Ampex Electric and Manufacturing Company in San Carlos, California, in connection with the electronics firm Dalmo Victor. The young company built compact electric motors and generators for wartime radar equipment. Even its name carried the founder's signature. AMP came from Alexander M. Poniatoff, while EX stood for excellence. But when the Second World War ended, military orders collapsed. Ampex was technically capable, but it had no obvious peacetime product and very little time to find one. Its rescue would begin with two machines brought out of defeated Germany. During the war, American Army Signal Corps officer Jack Mullin encountered German magnetophone recorders. These machines used magnetic tape and high-frequency alternating current bias to produce sound with a clarity that shocked American listeners. Back home, Mullin rebuilt the machines and began demonstrating them. One of the people who immediately understood what they could do was not an engineer. He was one of the most famous entertainers in the world. Bing Crosby was tired of live radio. His weekly program had to follow a rigid schedule. Mistakes could not be removed, and at times the show had to be performed twice for different American time zones. Crosby wanted the freedom to record once, edit the best performance, and broadcast it later without a noticeable loss in quality. At first, recordings made on large lacquer discs were not good enough. Then Crosby heard Mullin's magnetophone demonstration. Magnetic tape could be cut and joined. A bad joke, a wrong note, or a technical mistake could be removed. A stronger moment from one performance could replace a weaker moment in another. Ampex decided to build an American professional recorder based on this new understanding of magnetic recording. By the spring of 1948, the company had a working prototype, but not enough money to manufacture it. Then an envelope arrived. According to a first-hand history preserved by the Engineering and Technology History Wiki, there was no elaborate cover letter inside. There was simply a check from Bing Crosby for $50,000. That money allowed Ampex to begin production of the Model 200. The first machines went to Crosby's operation, and the Model 200A entered regular professional broadcast service in 1948. Ampex had not invented magnetic recording. German engineers, Jack Mullin, 3M, and others had all been essential. But Ampex turned those ideas into dependable equipment that American broadcasters could use every day. The machine saved the company. It also changed the meaning of a recorded performance. Before tape, editing audio could mean working with fragile discs and irreversible cuts. With magnetic tape, sound became physically rearrangeable. Engineers could cut the tape with a blade, remove a section, and splice the ends together. Recordings could be reused, copied, delayed, and assembled with a flexibility that radio had never possessed. Ampex machines spread through broadcast networks and recording studios. The company also built specialized recorders for telemetry and military testing, where several streams of information had to be captured at the same time. That multi-channel experience helped open another door. Guitarist and inventor Les Paul used Ampex equipment while developing sound-on-sound and multi-track techniques. By recording new performances alongside earlier ones, a single musician could build a layered production that had never existed as one live event. Ampex did not create modern studio recording alone. Les Paul, tape manufacturers, circuit designers, musicians, and many other engineers shaped the process. But Ampex equipment became part of the foundation beneath overdubbing, stereo production, and multi-track recording. The company had transformed sound by making time editable. But sound was the easy problem. A television signal carried vastly more information. To record it with a conventional fixed head, magnetic tape would have to race through the machine at an absurd speed. The reels would be enormous, the tape consumption ruinous, and the mechanism almost impossible to control. Ampex now faced an engineering problem that had defeated some of the largest electronics companies in the world. The breakthrough came from changing which part of the machine moved fastest. In an audio recorder, tape passes a fixed magnetic head. Faster tape can store higher frequency information, but video requires far more bandwidth than sound. Simply accelerating the tape was not a practical answer. The Ampex team used 2-inch wide tape and a rapidly rotating head wheel. The tape itself moved at a manageable speed, while 4 small magnetic heads swept across it in succession. The result was extremely high head-to-tape speed without forcing hundreds of feet of tape through the machine every second. Each head wrote a narrow track across the width of the tape. Frequency modulation helped convert the video signal into a form the system could record and reproduce with broadcast quality. It was a mechanical solution to an electronic problem. The machine that produced the decisive public demonstration was known inside the project as the Mark IV. The first hand-built customer units were designated VRX-1000, and the standardized production machine became the VR-1000. On April 14, 1956, Ampex unveiled the system at the National Association of Radio and Television Broadcasters Convention in Chicago. CBS executive William Lodge addressed the audience. Moments later, the monitors replayed his image and voice from magnetic tape. The response was immediate. Broadcasters had just watched live television become recorded television. Ampex's own later history says the company received 45 orders within a week at roughly $45,000 per machine. 16 early VRX-1000 units were hand-built, while full production of the VR-1000 began. On November 30, 1956, CBS used an Ampex machine for a tape-delayed network news broadcast from Los Angeles. The IEEE later recognized the Ampex recorder as the first practical and commercially successful videotape recording system. Television no longer had to disappear the moment it was transmitted. Once television could be stored, the structure of broadcasting changed. Networks could delay programs so viewers in different American time zones saw them at the intended local hour. Productions could correct mistakes without reshooting an entire program on film. Recorded material could be replayed, archived, exchanged, and eventually edited into entirely new sequences. Ampex's 2-inch quadruplex format became the professional broadcast standard. The IEEE milestone record describes the system as the industry standard for roughly 20 years. The engineering team also became a remarkable source of future talent. A young Ray Dolby worked on the VTR electronics before leaving Ampex, earning a doctorate and founding the company that would put his name on audio systems around the world. Ampex technology moved far beyond television studios. Its instrumentation recorders captured high-speed data generated by aircraft, sensors, and military tests. An Ampex FR900 recorder was selected for NASA work connected with the Lunar Orbiter program. Decades later, restored Ampex equipment helped recover higher quality versions of historic images. including the first photograph of Earth seen from the vicinity of the Moon. In 1967, Ampex introduced the HS-100 magnetic disc system for sports broadcasting. It could hold a short segment of video and play it back slowly or freeze the action. Ampex did not invent every form of instant replay, but its equipment helped turn slow motion into one of the basic languages of televised sport. By then, Ampex technology touched radio, records, television, surveillance, space imaging, data storage, and live sports. The company had solved problems the world did not know how to solve. But dominance created a dangerous illusion that Ampex would always be the company defining the next format. During the 1970s and 1980s, professional recording became more competitive. Studer challenged Ampex in high-end audio. Japanese manufacturers such as Otari and Sony built capable machines and pushed aggressively on price, size, reliability, and new formats. Ampex still produced sophisticated equipment, but sophisticated did not always mean commercially successful. Its ATR-124 audio recorder offered extraordinary performance, yet its high price limited sales. Ampex withdrew from major parts of the professional audio recorder market in the early 1980s. Video was changing too. 1-inch systems, cassette-based professional formats, smaller electronics, and digital processing reduced the advantage of enormous 2-inch machines. Customers increasingly wanted equipment that was cheaper, more compact, and easier to maintain. This was not a simple story in which Japan invented and America failed. Ampex itself had developed helical scan machines, digital video systems, compression technology, and advanced storage products. The deeper problem was that Ampex repeatedly created valuable technology without building a stable business around the next transition. Technological pressure was already rising when the company entered a new ownership era. That change would turn a long decline into a rapid contraction. In 1987, an investor group led by Edward Bramson acquired Ampex from Allied Signal, in a deal reported at approximately $479 million. Later proxy material filed with the SEC describes the company at the time as employing roughly 6,700 people and generating more than $500 million in annual revenue. Those figures come from a later adversarial proxy fight and should be treated as approximate. But the direction of travel is not in doubt. Sales weakened, restructuring accelerated. Ampex cut jobs, changed senior managers, and sold or separated operations as it tried to reduce costs and escape declining analog markets. According to that same account filed with the SEC, annual revenue fell to about $318 million in 1991, $238 million in 1992, and $170 million in 1993. By the end of 1993, the document says the workforce had fallen to roughly 800. No single executive, investor, or foreign competitor destroyed Ampex. The company was being squeezed by new formats, expensive legacy operations, debt, shrinking product markets, and repeated management disruption. But restructuring also had a cost of its own. When experienced teams disappear and core businesses are sold, a technology company can lose the institutional memory required to turn inventions into products. In October 1993, Ampex announced that it would sell its videotape business and concentrate on digital storage. Its recording media operation was separated and later became Quantigi. Ampex was trying to escape its past. The problem was that it could not decide which future to pursue. The company moved toward digital storage, but that strategy did not remain stable. In 1999, Ampex started an internet video operation called iNext TV, hoping to participate in the emerging market for online media. The timing looked visionary. The business results were not. Ampex closed iNext TV's New York internet video operation in 2001 and stopped funding its other affiliates. Its own Form 10-K recorded a disposal loss of approximately $10.3 million. For 2001, Ampex reported total revenue of about $46 million and a net loss of $28.1 million. The entire company was now producing less than 1/10 of the annual revenue attributed to it around the 1987 acquisition. This was strategic whiplash: tape to digital storage to internet video, then back toward the specialized recording business that remained. Changing direction can save a company. Changing direction repeatedly can consume the time, money, and engineering focus needed to make any one direction work. What kept Ampex alive was not the return of its old product empire. It was the continuing value of inventions the company had made years earlier. Ampex held a large portfolio of patents covering digital image processing, compression, storage, and retrieval. Its technology appeared in products far removed from the giant broadcast machines of the 1950s: digital still cameras, camcorders, DVD recorders, and other imaging devices. Licensing brought in significant revenue during the middle of the 2000s. In a sense, Ampex engineering was still succeeding even while Ampex as an operating company was shrinking. But patent income has an expiration date. A key rapid image retrieval patent, responsible for much of the recent licensing income from digital cameras and camera phones, expired in April 2006. Those licensees then stopped paying royalties tied to that patent. Other patents remained, but the company's own bankruptcy disclosure warned that licensing would eventually stop being profitable as the portfolio expired. Royalties could delay the crisis. They could not rebuild the empire. By 2008, Ampex was carrying obligations that its remaining businesses could not support. Its bankruptcy disclosure listed about $59.6 million in outstanding debt in March of that year. It also described heavily underfunded legacy pension plans and future required contributions that the company could not meet from operating cash flow. On March 30, 2008, Ampex and related companies filed for Chapter 11 protection. Chapter 11 did not mean the machines stopped and the company vanished overnight. It was a legal reorganization intended to restructure debt and preserve the operating businesses. At that point, Ampex Data Systems was still building high-performance recorders for defense, aerospace, flight test, and intelligence applications. The mass-market recording empire was gone, but a specialized engineering business remained. In October 2014, Delta Information Systems completed its acquisition of Ampex Data Systems. Delta said the company would continue operating under the Ampex name as a wholly owned subsidiary. Ampex still exists today. It no longer defines how television studios record the world. Instead, it builds rugged systems that capture, process, store, and secure high-value data on land, at sea, in the air, and in space. The company that once recorded television now records flight test data, sensor information, and mission-critical imagery in some of the most demanding environments on Earth. Ampex did not disappear. It became almost invisible, still recording what matters, but far from the studios and networks it once transformed. Its story is a reminder that inventing the future and keeping control of it are two very different engineering problems.